Welcome to the Internet Report, where we uncover what's working and what's breaking on the internet and why. It's a new year. Happy 2021. We're all glad to be on the other side of 2020. We're back from the break. Luckily, there were no major outages or incidents that happened during that period, so it was nice and quiet, which is just the way we like it. But then, we came back yesterday from
Started
break.
it with a bang, yep.
Yeah, and Slack had a really significant, lengthy incident yesterday. So we're going to spend a lot of time talking about that and kind of going under the hood, because we don't really have any other news to report.
Yeah, but we do have a fun expert spotlight session today with Forrest Brazeal, who is a cloud architect, among many other things he does. So after the Slack outage, stay tuned for that in the expert spotlight session.
Yeah, absolutely. It's going to be really, really good. Great interview. And Forrest is so talented and entertaining, has great drawings, and we'll show you some of that stuff. So lots to cover today. So the, kind of the topic of the day that a lot of folks have been asking us about is what went down with the Slack outage. Now, we have to say, Slack hasn't yet issued an RCA detailing kind of what the cause of the issue was. So we're going to kind of just stick with what we saw during the outage and kind of show you all of the gory details on that.
Started around pretty early in the morning from a Pacific perspective, right? It was around 6:30.
Mm-hmm. So around 6:30 Pacific time. You're on the East Coast, 9:30 there. You probably would have noticed it. I was not on Slack at 6:30 a.m.
And so that's interesting. I started noticing it more closer to around 10:15. And I think this degradation that we see in the availability, that stepped slow degradation. I think maybe that's probably the reason why I didn't really see it at 9:30, but around 10:15 it was all out.
Yeah, and that's interesting. So we're looking at right here where I have my mouse rolled over. It's 14:32, so it's 9:30 Eastern time, 6:30 Pacific time, and that's kind of where it starts to really manifest itself. And you're right, it's kind of interesting because sometimes we see with outages, you just see this sharp drop off. It's available and it's not available. It's binary. But here we're seeing kind of a gradual step down in availability depending on the location. And then at its worst, we see kind of this, chasm here. And then it had a similar recovery. It seemed like it was gradual and staged. And then it wasn't until about 4 hours later, 1838 UTC. So that's
around 10:30.
10:30 Eastern time,
Pacific.
1:30 Pacific time that we really switch 10:30 Pacific, 1:30 Eastern time, that we start to see there's too many time zones, that we start to see that it's really kind of fully back online.
And
it's
this kind of matches Slack's kind of status as well, where around I think 10:15ish Eastern, again just 7:15 Pacific, they started acknowledging the outage, which again, it was great of them, right? To be transparent and to say, yeah, we know there's something going on. And then around 12 p.m. Pacific was when they said most of the issues, at least with respect to users, using Slack to communicate, was resolved. However, there was some Google Calendar and Outlook issues that were still persistent, and that went really long. It was almost, till midnight. They were still resolving those issues.
Yeah, it's I think around 4 p.m. ish, they were saying that it was mostly resolved for users. But yeah, it went pretty late, and that was really interesting. I mean, typically when we've seen something that this is as widespread as widespread as it is and
Yeah.
affects so many users, it's not typically something that's related to the network, right? And we'll take a look at that in a little bit, but just if we look a little more closely on what we were seeing, like, all this red here, right? Like we were seeing a few different things. One of them was HTTP errors. So we were getting like a 503 service unavailable from the servers, front-end servers. And we were also seeing, you see here, receive errors.
A lot of timeouts.
There's a lot of timeouts. And that's really just an indication that the server's taking so long to respond. It's just our test is, we're just timing out from that standpoint.
Yeah, we have a threshold when we set up the test, and that's timing out. So hence we see them as a timeout. Which is kind of interesting. Like either the server is responding, saying I'm not available, or like rejecting with a 503, or the server is just not taking. I mean, it's taking too long to even respond.
Yeah, and it could very well be that it would have given a service unavailable error if we gave it a little bit more time.
Exactly.
And that's kind of interesting. We see here, like if we look at like just how long it was taking to receive these error messages, it was we do see kind of this response time spike. And if we look at like a little bit more closely at what's actually contributing to this response time, we see that, for example, DNS and Connect and SSL, very small proportion of overall response time is really wait time. And often that's really due to the server, like a lot of it is that server processing time. Could also be some reverse path, but we know that the network is looking pretty good. So it's really that server that's taking a long time to just even respond to a
respond. Yeah. That's the pie chart. It's actually really interesting because again, it's another proof point that it's most likely not the network, and it's actually the backend server and the application that's it's becoming sluggish, probably overloaded. We don't know yet as to what the RCA looks like, but I think we confirm that again with going into the network connectivity that we're seeing right now with path visualization here, which is just showing you the network, connections to slack.com, which is to Slack's edge.
Yeah, exactly. And it's really interesting, just even, we see, again, we're confirming the network paths are clear, which we kind of already know from the application layer because we're getting responses from the server. So we know kind of like, we're able to reach the server. But it's interesting, even just looking at kind of like Slack's architecture here, we see that, they're not front-ended by, even though they use AWS to host their edge servers, they are not using CloudFront, which is AWS's CDN service.
But they're not using CloudFront to front end the actual server.
Or any other CDN, right? Like exactly. They really are just, they're using like what looks like DNS load balancing to, effectively map users based on their location to their instances that are hosted within AWS. That's really interesting just from an architecture standpoint, because we see in a lot of like instances, heavily used applications, they're often fronted by CDNs. Now,
this pattern that we're seeing here was common across this particular, UI right now is showing the slack.com. But we saw that with, while connecting to the API, while trying to log into our own instance of Slack as well. This architecture was pretty standard across their services.
Yeah, so they had this, we're seeing like that common architecture across all of the Slack associated services and also a common outage, right? Like we're seeing that like the similar behavior that we saw here with like their website is also what we were seeing across like their APIs and other services, even our own Slack instance, if you will.
Right. So it's pretty pervasive from an impact perspective, but also from the number of services that were impacted. Like Slack.com, just their homepage was not available too.
Right. So really widespread, which again is another indication this is probably something that's application related, even on the back end. Like, sometimes there can be network issues if you're connecting from like your edge service to like an origin or a data center, but again, that seems pretty unlikely given, where these edge servers were located and where they would have to all like it'd have to be like some common fault point, which seems pretty unlikely. Usually data centers and other origins would probably have some redundancy in terms of connectivity. But anyway, so so not front-ended by a CDN, but interestingly, if we look at like the components of the page, a lot of the components of the page are fronted by a CDN provider. So they're still leveraging those services. Yeah, and it's kind of interesting if we were to look at a little bit more closely on what we were seeing when we were able to get a response.
This is actually interesting because we were trying to like see if it could be like an authentication issue, you know, like you're unable to log into Slack. So we set up this script that actually tries to take us to our instance of Slack. So the expected page here should have been to sign into your account.
Right.
But we never even got there. So, you know, it was definitely not something to do with authentication in the back end or anything like that in here, which
so again, it was like the service was hard down. It wasn't like, you know, there was not that, you know, like you could load even their home page as normal. It was really like it couldn't even do that much, right? So we see here, like under normal conditions, we'll actually get a page that looks like this, that's like prompting a login. And so that's what we'll see, but that's what we see when the issue resolved itself. So the other interesting thing about this was that because a lot of like media outlets kind of, you know, they knew things were going down, you know, like people were reporting Slack issues, and a lot of folks like went to like services like Down Detector, for example, which is basically like crowdsourced, right? Like you have people that are kind of self-reporting when they have issues.
Very subjective, right? Because you're reporting that something's not working, but you're not really clear on what it is. Like, was it your, you know, Wi-Fi connectivity? And this is like, you know, not an enterprise crowdsourced service, right? It's basically a consumer service. So it could be anything that people thought was wrong. But there was a lot of chatter with like Zoom was going down and Teams was going down. It almost seemed like, you know, God didn't want Workday to start on Jan 4th. But I think we noticed that that was not the case at all.
Yeah. It seemed like, you know, maybe there were some folks who had went to like one of these services like Down Detector and then also saw like other things like, oh, people are also complaining about like Zoom and Teams and other things. And, you know, like to your point, again, this is so subjective, could be anything. And, you know, those sites all reported that they were available at that time. And we can see even here, like, you know, based on our tests that like around that same time, so this is like 1440,
this is Zoom, right? What we're looking at here is Zoom.
That's correct. So we're looking at like we're looking at Zoom and just what their availability looks like, and it's all green. You know, they were available during you know, like all day yesterday, and pretty much almost every day. So
it looks like they've been available all through Sunday. So if you want to move right there, then I mean it's very to the left there. It clearly shows that they were up and available.
So lots of, you know, so this is, you know, really kind of the clear evidence when people are reporting issues, whether they're consumers that are reporting issues with a service that you're responsible for, or if it's just like, you know, employees that are like, hey, I can't reach Zoom, or I can't reach like WebEx or some other service that they might be using. You know, you can very quickly determine, like, is this subjective? Is this something that's isolated to an individual, or, you know, verify one way or the other if there's actually a service issue.
Right. And I think like for an IT team, like if you're running behind Down Detector to see if something is wrong, that's probably not the right place to start, because again, to the point we were making, it's too subjective. You don't really know what's going on, and so that's again why hard data makes a lot of difference. Like, you know, just being able to see this and say, yeah, you know, the Zoom is not really an issue, you know, and prioritize what really is, which you know, yesterday's main concern was just Slack.
Absolutely. I mean, I think like a lot of enterprises today, they have dozens, if not hundreds of applications that they're running for their workforce or, you know, other parts of their business. And, you know, like there's a lot of noise out there, right? Like, and
Yeah.
so to your point, prioritizing where you're going to spend your time and cycles, just kind of knowing
Makes life easier.
is,
Yeah,
yeah.
yeah, yeah. And it
And we
being able
can,
to contextualize it in a way that, that you can actually be actionable in that particular
yeah,
case. Like for instance, like if it's an application, like being able to quickly even say, in the case of Slack, whether it's the application or the network, so you're even, utilizing the right team's resources to come and troubleshoot. I think that's really important with the kind of data you get as well.
yeah, absolutely. And so speaking of outages and cloud and resilience, we talk a lot about kind of just like issues with like having just a few infrastructure providers, like, the three big cloud providers, the CDN providers like Akamai and Cloudflare, and how when they experience an issue, how it can just kind of have catastrophic impact because they're really like kind of where everything is like
Everything is
lives
right
these
now.
days, right? So so really excited. Coming up next, we have expert spotlight. As Archana mentioned, Forrest Brazeal, you're going to sit down with him, and you guys are going to talk about resilience and the different cloud providers. So stick around for that.
Hey guys, welcome to the Expert Spotlight. This week we have Forrest Brazeal joining us. Forrest is a cloud architect, writer, speaker, cartoonist, the list goes on. But Forrest is an AWS serverless hero. He's based out of Charlotte, North Carolina, and currently works for a cloud guru, a company that is dedicated in educating people about the cloud. So we thought it made perfect sense to have Forrest on the call today, talk to us a little bit about the cloud, specifically dipping into some resiliency aspects, and just educate us a little bit more. Forrest, welcome to the show.
Thanks so much, Archana. It's wonderful to be here.
Thank you. So the way I got introduced to you was I subscribed to your blog, Cloud Irregular, a long time ago, but then one article specifically caught my attention, which was in relation to the AWS Kinesis outage from Thanksgiving time. I thought you had done a really good job talking about, the incident itself, but also delved into some of the resiliency aspects and the dependencies that exist. So I thought that might be a good place for us to start today's conversation with. So one of the most common, and what are the most common and possibly dangerous resiliency gotchas that get overlooked while designing a cloud-hosted application?
Sure. Well, and it's great to hear that someone reads the blog. So thanks for that affirmation there, I guess. And just for context, for any listeners that may not be aware of what we're talking about, this Kinesis outage happened in late November. It was just before Thanksgiving here in the United States. And I think about a day-long outage really with the AWS Kinesis service ended up kind of cascading to take down a number of other services. So a lot of apps and systems that rely on AWS were offline for a period of time, and there wasn't really much you could do other than just sit there and wait for AWS to get it back up and running. So that's the context of what we're talking about. And you asked the question about what are these common resiliency gotchas. And I just want to be very clear up front. I don't work for AWS, right? I wasn't in the room. None of us can really know what went on there other than specifically what they put out in their root cause analysis that came out a few days later. And I highly recommend reading that if you haven't had a chance to check it out. It's very, very interesting.
Detailed root cause analysis in there as to what happened, what they missed, and then going back and recorrecting some of the things that they had mentioned. So yeah.
Yes, yeah, very, very highly recommend reading that. So my goal in anything that I say today is not to diss AWS. They did a fantastic job of recovering from this. This happens to everybody, and that gets to your question, Archana, which is what are these common resiliency gotchas that you can avoid if you're trying to build, whether it's on AWS or elsewhere. And really the biggest thing that comes to mind, this is not cloud specific, this is as old as time, is the biggest mistake people make is they assume that their resiliency measures are going to work and they haven't actually tested them. I started my career in the cloud as a DBA. The most classic form of resiliency is backup and restore. That's what DBAs are all about, right? And we did restore testing on a regular schedule. You can take backups all day long. You could take diffs, you can take log backups, but until you've actually confirmed that you can get that data back up and running, it's not corrupted, and that you have a repeatable, predictable framework of time for doing that, then you don't have backups, right? this is why I'm so excited. I think that AWS at reInvent just a few weeks ago announced something called the Fault Injection Simulator. I haven't had a chance to play with this yet. I'm actually not sure if it's truly available hands-on or if it's just one of these announcements that won't be available for a few more months. But it's this idea of bringing chaos engineering into your workplace where it's accessible to you without a lot of really specialized knowledge. The idea that I want to give myself some idea of what the range of failures are that can occur. What will happen if my storage suddenly disappears in the cloud? What will happen if all of a sudden you just cut the link to my identity service, which in fact is what happened in the Kinesis outage, where it was linked, unbeknownst to many, to the Cognito service, which people use to do authentication and authorization. What happens if that were to suddenly go away? Would I fail gracefully? Would I just have to be offline for a period of time? And we should be very clear to make the point that sometimes it's an okay contingency plan to be offline for a period of time. If that's what your SLAs are with your customers, if it makes sense cost-wise, you know, to endure the occasional couple-hour outage versus having to pay for, I don't know, replication to another region, I should say, that could be totally reasonable. But you don't necessarily know how exposed you are until you've actually set up those tests. You've done the game days, you've done the, the chaos engineering, the outage simulations, whatever the case may be. So do that. That's the most common mistake people make. They take the cloud provider's word for it that, yeah, we handle downtime under the hood or whatever, and then they just don't ever test to see how exposed they are. So definitely know what your risk is.
That's very interesting. I came from a testing background myself. Well, I used to work for Cisco a long time ago, and we used to test service provider solutions in there. And one particular Q&A, like subject or category that we would like forcefully like and make sure we test is this resiliency piece, right? Like, literally like snap cables out and see what happens to the entire system. And it's interesting in the cloud. You mentioned people don't do that, but also that's the challenge of the cloud. You don't really own and control, the services or the hardware in there. So how do you actually simulate kind of this chaos in there? You said Fault, what was the AWS service again?
Fault Injection Simulator. It's brand new. It was literally just announced in December at reInvent. So something I'm looking forward to playing with in the new year. Of course, there's existing chaos engineering discipline that's out there through companies like Gremlin and through work like what Netflix has done with Chaos Monkey and its many descendants. So definitely recommend looking into that if that's not something that you're thinking about today. Don't let that necessarily push you to a point where you're making very expensive redundancy decisions that don't have the ROI that you would need them to have. But it's important to know how exposed you are.
Yeah, that's actually pretty cool. I learned something new today. That's great. So, you meant in the Kinesis incident, we noticed, and this was something AWS came out and spoke as well, that there was Cognito that was impacted, CloudWatch was impacted, and you touch upon this in your blog post in much more detail. But what are some of these like unknown and hidden dependencies within a cloud ecosystem that's just waiting to be revealed when yet another outage strikes?
Yeah, well, and first, I think that's part of the problem is that a lot of them are unknowns. I mean, there was never a reason for any customers of AWS to know that Cognito had a dependency under the hood to Kinesis. I mean, it wasn't like you're getting any direct benefit from the Kinesis service if you're using Cognito. It was some analytics thing they were doing under the hood to analyze like API usage or access patterns, right? There was no need for a customer to know that until the day that Kinesis went down and took Cognito with it. And of course, there's all sorts of other dependencies like that under the hood that we'll never know about until the day that they're exposed by some outage. That said, AWS in particular has a relatively large and shallow dependency tree, and there are some core basic services under the hood where if one of those goes down, a lot of people are going to have a bad day. EC2 is certainly one of those. S3 is certainly one of those, and we saw that back in 2017, right? When S3 went down, it seemed like it took half the internet with it.
Interesting on the S3 outage because the impact, well, S3 went down, EC2 went down too, but there were some web pages that were not loading because one of the critical components on the page was an image that was sitting on S3. And just the way, a particular page was architected, I don't want to say who exactly this service provider or this vendor was, but it was interesting. We're like, why isn't this page loading? Just because S3 is down and image is not a critical dependency. So that's another angle as well, but yeah.
Yes, well, hilariously, I think with images on web pages, perhaps the most infamous example of that is the AWS status page itself, which had all sorts of problems, right? Remember that in 2017, where the image that showed X or green check mark was not able to load because it was hosted on S3, which was down. So the status page was saying everything was fine because it was just having to use those cached images. So yeah, it's an example of something that you wouldn't know unless you'd actually simulated that failure scenario and see what goes away when you pull your storage out from under the hood. So S3, EC2 for sure, Route 53, which is AWS's DNS service, on the occasions when that has gone down, it's been very bad for people. Now, it's important to remember that most of these services are usually limited to a regional scope when they go out. For example, the Kinesis outage was limited to US East 1, as I believe was the S3 outage. Route 53 goes down, that could potentially be a worse problem because that's not region specific, exactly. Right? It's DNS, it's everywhere. IAM is the same thing. If you have an IAM problem, probably, well, let's hope everybody doesn't have a problem. That could still be just, a component of IAM in a particular region that would be having issues. We've seen that in the past. But you don't have quite as much ability to protect yourself in terms of how you architect from these services that don't isolate themselves by region, don't expose a region limited fault tolerance to you.
Right. Route 53 is a great example in terms of the impact of DNS. And this we noticed, do you remember the Dyn outage that happened a few years ago? I guess it was 2016, where Dyn is a DNS service provider and they were DDoSed. And we found out that a lot of companies did not have resiliency with respect to their DNS provider itself. So again, like it seems like, something outside, it would seem simple. Yeah, you need to have resiliency everywhere, and DNS is probably something that you should. But until it actually happens, we did not see a few service providers have redundancy from a DNS perspective. So that's absolutely a great point. Like depending on the service, the impact could either be regional or global. And if it is global, in some cases, yeah, you can protect yourself, but then sometimes you're just left dead in water.
Right. It's a little bit of a black box. And that's part of the reason why we sign up for cloud services and build on them in the first place, because we want to do less management. We want to have less to worry about. We want to abstract these responsibilities down onto people who work for the cloud provider. But yeah, the flip side of that is when you have an outage, to some extent, you can sit back and relax a little bit, but that has its own form of stress, right?
It's like when Slack went down yesterday. Everybody was sitting back and relaxing because they couldn't communicate. Well, that's great. And talking about resiliency, I think one of the other interesting things that you did last year was write a book, which was an introduction to the cloud. And you talk about one particular chapter in there that's about resiliency and reliability. Can you just give us a little bit more insight into that?
Yeah, so the book is called The Read Aloud Cloud. It's available wherever books are sold. It's from Wiley Publishing, the makers of the For Dummies books and things like that. And it's sort of an outgrowth of a long-running cloud-related webcomic that I've done for A Cloud Guru. So there's lots of cartoon drawings in the book. It's very accessible for all ages. But really, it's designed to be something that you can hand to your non-technical friend or family member, help them understand what is this thing called the cloud? What are the jobs that you can have in the cloud? It's hard for us, I think, sometimes to take those really abstract concepts and make them real to people, right? What does a cloud architect build? Why does that matter? What is cloud resiliency? Why does that matter? And in the chapter of that book that talks about it, we go through kind of in layered detail, what are the different steps that these cloud providers take in order to give you more resiliency than you would have if you were just, for example, running a blade server under your bed, like a lot of small businesses used to run, and some still do, or just a single server rack in your closet. What is the cloud giving you that you wouldn't have if you just went back to that, right? So yes, we talk about these occasional, terrible outages where half the internet goes down for half a day. But there are a lot of resiliency steps that are being taken by the cloud provider. And that starts with, of course, things like, redundant power supplies and network interface cards and everything in the servers and racks they have in their data centers, up to multiple data centers that are in availability zones, right? A lot of people tend to think availability zone is a one-to-one relationship with the data center. That is not true. An availability zone often has multiple data centers in it. And then, of course, you have multiple availability zones that are put together to make a region, right? And, you go on from
regions and you
yes.
that onto it. Yep.
Exactly. So the book talks you through all that, and even talks about building cross-region architectures. And I think at that point you've probably lost half the audience that would be reading a book like that. But it gets up to that point, and then it's like, okay, this is as far as we should take this chapter. But I think we don't often even give enough credit to the software expertise that's the cloud provider is bringing as well, right? Things like cell-based architectures and shuffle sharding. If you read what AWS does to limit blast radius of failures inside of those data centers, inside those availability zones, it's really can only come from years and years and years of exposure to failures, motivation to limit failures, right? And the traffic coming from hundreds and thousands of customers, limiting things like noisy neighbor problems and all of that. So you're getting access to a real hive mind of innovation with the cloud that does decrease the frequency of outages over time. Now, when those outages do occur, they may be bigger and more catastrophic because they affect more people, right? But that's the trade-off that you make.
So these concepts that you talk about, right, like, the people are not aware of, like availability zones, inter-region, those are well documented and those are well marketed. And so people understand that. But the more nuanced details of it, like, what would you recommend for someone who's just starting out in the cloud trying to build this? Do you recommend they any place they could go to understand this, or is it best to just sit down with your cloud provider and just ask them all the specifics that you need to with respect to understanding what cloud providers do to protect you from these type of outages or scenarios?
Yeah, definitely sit down with your, your TAM, your solutions architect, whoever you're working with on the cloud provider side. Definitely make yourself exposed to all of the great information that comes out at places like reInvent. There's, if you're curious about things I mentioned like shuffle sharding and cell-based architectures, there's wonderful reInvent talks available about that online. You can Google and find those. I work for A Cloud Guru, which is a cloud education company that spends a lot of time helping people to understand this. So of course I have to drop in a plug for them as well. To some extent, it is going to be about evaluating your specific use case, your specific risks as well. I mentioned earlier about not putting in redundancy just because you never want to have an outage. I mean, there's a realistic aspect to that. A certain amount of downtime is acceptable. You just have to decide what that is based on what you're willing to pay. In the wake of the Kinesis incident, as I like to call it, you heard a lot of people saying, oh, we need to go multi-cloud. We need to architect our workload so that if AWS is down, it can run on Azure or vice versa. You're introducing a lot of additional complexity into your architecture when you do that, of course. You're limiting your ability to take full advantage of a lot of the services that run natively on the individual cloud providers. You're sort of limiting yourself to the lowest common denominator of services, storage and compute primitives that are available on all the clouds. And so that has measurable negative impacts for you every day in terms of what you're actually having to be responsible for. So you just have to weigh those trade-offs and see how much you're willing to expose yourself to risk.
Yeah, that's fair. You give me an interesting thought on multi-cloud, and maybe we will have you on the show another time to talk about it, is when is it best to go multi-cloud versus not going multi-cloud? For this week, Forrest, thank you so much for being on the show. This was really great just listening to you, and I learned a few new things today, and I hope our audience got something out of it as well. So thank you so much.
It was wonderful to be here. Thanks for having me, Archie.
All right, that was such a good interview with Forrest. Oh my God, he is so knowledgeable. And again, if you haven't checked out his blog post or his website, forrestbrazeal.com, definitely go there. I mean, you'll not just learn, but you'll have a great laugh too. So with that was our show. Don't forget to hit subscribe and follow us on Twitter. And as always, if you have questions, feedback, if you'd like to see a special guest on the show, hit us up at internetreport@thousandeyes.com. And finally, if you haven't gotten your t-shirt, again, send an email to internetreport@thousandeyes.com with your size and your address, and we'll get that right over to you. Until the next outage breaks or next week, we'll see you soon.